Hello, my name is Christoph Greb and I am application scientist here at Leica Microsystems, and I'm going to show you how the LMD here in my back, Laser Microdissection, can help you in terms of spatial proteomics. First of all, I'm going to give you a short introduction, a short presentation, and to get an overview of what we are going to see here in this workshop is spatial proteomics and the question how spatial proteomics can help you or how the LMD can help you in your spatial proteomics workflow. Short introduction or what LMD is. So we are sending a UV laser to the objective, and from the objective the UV laser hits then the specimen, and the specimen is cut with this laser and the dissectate. So what we are cutting out is then just dropping down by gravity and in a collection well, and with this dissectate you can then do your downstream approach. In this case here today, this is proteomics. The complete workflow would look like the following. So you would do your normal sample preparation, then you would do the imaging. And here in this case, this can be, of course, some kind of a Leica device. So in this case here, this would be the LASX, but it could also be just a complete other imaging device. After this, you would then go, and this is the new stuff, I would say, you go to artificial intelligence software, where you can then define your regions of interest with this artificial intelligence software. This can be self-made software, this can be commercial software. Today I'm going to show you our solution, and this is Aivia. From there you go then to the LMD, where you then cut these regions of interest. And yeah, with the dissectate, as I just told you, then do your downstream approach. This can be mass spectrometry and so on. As I said, the imaging device can be any imaging device. It could also be Mica, as I pointed out in this picture here. Could also be the LMD device itself, or just any other kind of imaging device. From there, we go in the workshop back to the LMD, because the Aivia software is at the LMD. And afterwards, again, we stay at the LMD and where we do the dissectation then. The central point between the AI software and the LMD is XML. So the language both softwares are speaking is XML. So that's why we will have a short look on this. Good. LMD software is here in the middle of this slide, and from there we have also other opportunities. I would say LMD software internal opportunities to detect automatically regions of interest. We will not talk about those here. We call them auto detection module, but today we are talking about the left side here, which is the ROI import. So how to get your regions of interest from other softwares to the LMD. As I just said, so you can do the imaging with any kind of microscope, and then you do your segmentation with some AI software, and put these information to the LMD via XML files. The very important thing in this case is that we need reference points. So the microscope or the LMD has to know where it is, and that's why we need 3 reference points. I will show you on the microscope how we can handle this with the LMD. And with the information of these 3 reference points, we also know the where the regions of interest are sitting on your slide. And on the right side, you can see just an example for such an XML file. I will not go into detail in this case. Just some examples what you can find and what you can see. For example, with Aivia here, so you can see some kind of a mouse brain on the top. This is what we are going to do today with the LMD, where I just identified some neurons. And on the bottom, you see just other examples with rat kidney. It can also be a little bit more complicated, as you can see here in this mouse testers, where you can find on the one hand the circle structures or the spheres at the top, but of course you can also find other structures, as you can see on the bottom, these kinds of tubules. This is just a short introduction, but from here, let's go to the workshop. Then let's have a first look at the hardware. So this is one of our LMDs, Laser Microdissection device. There is 2 of them, LMD6 and LMD7, so this is the bigger one, the LMD7. The base of this device is our DM6B microscope, which is our high-end upright microscope for life sciences. So as I just said, so it's an upright microscope, so that is why we have one special thing with LMD at Leica. But let's have a look on the system itself. So the laser comes out of this box here into the light path of the system, and then you can see here the objective. And at the objective, then it hits the specimen. And the specimen looks like this. So in this case, we have 4 of them. I will tell you something about these lights later. On the specimen, the laser cuts, and then the dissectate drops down. And below this specimen is this device. And in this device, we can put our collection devices. In this case, these are just normal PCR tubes. So since we are collecting via gravity with an upright microscope, we can just collect into anything which is below the specimen. So far about the main principle of it. And that just started already. So we have some kind of special hardware for the specimen. And this is these LMD slides here. They exist in, at the one hand, metal, and on the other hand, glass. There is not only glass or not only metal on these slides, there is a very thin and tiny membrane on these slides, and this is where you put your specimen on. In this case here, this is brain and liver. And this membrane is cut together with the specimen and then drops down by gravity. You can also not only collect into these PCR tubes, you can also collect, and this is very interesting for a lot of you, you can also collect into PCR wells. In this case, 384 well plates. What is more often used is 96 well plates. So also this is possible. Moreover, and we don't touch this today, you can also collect into special devices for living cells, so which are here, these Petri dish devices. Yeah, so far so good. From here, I'm going to introduce you a little bit about the software. So let's have a look to the LMD software. What you here see right now is the graphical user interface of the LMD. And here you can control everything. You can control the microscope itself. So you can change magnifications, you can change contrasting methods. You can even control the stage with this software. And moreover, you can control the laser. So you can fine-tune the laser according to your specimen. The specimen is now on such a metal frame slide I put on. And you can increase power, you can decrease power, you can increase the aperture of the laser and how fast it will run around your sample. Everything can be fine-tuned to your sample because there's people who want to cut tiny things, tiny thin things, and there's people who want to cut thicker wood or even living tissue. So you can tune the laser according to your specimen. What I wanted to show you is how easy it is. So you can just, in this case, draw an ellipse. And you can say, just press cut, start cut. And let's see what will happen. Okay. Dissectate drops down by gravity into the collection wells. And the collection wells can be seen here, by the way. So this is 1, 2, 3, and 4, because we had 4 PCR tubes, as I showed you in the beginning. And now I can also have a look into these PCR tubes, and I press collector. And now the system is changing the PCR tubes into the light path. And let's see. You can see I really collected it. So there's another one which I just cut before the session here. And with this function, you can then prove, okay, I really collected my dissectate in the collection well. From the basic introduction of laser microdissection, we now come back to the real workflow I wanted to show you. And remember, I wanted to show you how to cut some reference points, image this sample with the reference points, take this image information to Aivia, where we then afterwards identify our regions of interest with AI, and then coming back with these regions of interest to the LMD itself. Now I want to show you how easy it is to cut reference points. Reference points could be anything which is on the sample itself. So it's if there's some prominent scratch or point or whatever, you can also use this. It is easier if you just prepare your reference points yourself. And there's one nice tool you can use with the LMD software in this case, and this is the cut text tool. If I now press in the field of view, I can, for example, say T1, and the system then cuts a T1. This could be my reference point number 1. Then I could go just to another position. I do this now just as an example for you. Here I would say then this is my reference point number 2. And I would go to a third position, again, just for example, as an example. This would be then my reference point number 3. I did the same with another sample with a much nicer sample, which I have prepared already. With this information now, with this reference points, I go to the imaging machine. I did this with Mica already, and I'm going to show you the next step then. Open the image I took with Mica with Aivia. Let's go there. So now I opened Aivia, and I already imported the image which I took with Mica just before. You can see also the reference points, and this is maybe a quite nice thing to show because you see the orientation is different because the specimen tray of Mica is tilted 90 degrees compared to the one on the LMD. But we don't care because we have this reference point. So, and with the information of this reference points, we don't care which imaging device it was used, what orientation the image has, we don't care. Everything is fine with the reference points. My task, what I wanted to fulfill now is I want to identify these dark blue single cells. What I do first, I decrease a little bit my working area by using the ROY tool here, and I just make this ROY and crop it. Now I'm only working in this area, which makes the system, of course, faster instead of working on the whole image. Good. As I said, I want to identify the dark blue cells, but nothing else. So now I use the pixel classifier for this. And what I have to do is I just have to define what is background from my perspective and what is really what I want to identify. So let me just first define my background. Let me then define what I really want to identify with the pixel classifier. And these are these dark blue cells here. Or a third one. Here you can see we get already a quite nice preview. You can also check by switching this on and off. And again, I think this is really a quite good hit already. Good. This is now the parameters we are going with. And now I teach the parameters to the system. And with this information, I go back to the original image because I want now to use these parameters on the original image. Let's apply. This may take some seconds because the image is really big. In the meantime, I already prepared also another pixel classifier. So as I just said, now I use this one to identify the dark blue spots. I did another one just in between or in preparation of this workshop to identify the larger violet regions. I will show you in a minute. But here you are now. So now we identified a lot of these are dark blue cells. And I think this is quite nice already. But as you can also see, there's also some things we maybe don't want to have in the LMD. So that's why I'm going now to the spreadsheet. And from there, I can now identify or activate regions, as you can see right here. So this is just an air bubble, which I just delete, as you can see. And there's more on the side here, which I just delete. Let's go to the other side. Is there more we don't want? I think here on top. This we just delete. And I think with this we can already go. What we have to do now, tell the system here, where are my reference points? So for this, I use the annotation, and here especially the angle tool. Press the left mouse button, and now I go to the T of my reference point, because this is now what I really identify as a reference point. Press left mouse button and go to reference point number 2, which is here. Again, T, and from there I go to reference point 3, again in the middle of the T. Okay, so this is now a reference points. With this information, I can already go to the export function, and now I say outlines to XML for LMD, because what Aivia is now doing, it's taking this information, the reference points and the areas which I just identified, and puts this into an XML file. I can also play it a little bit with some settings. In this case, the dilate outlines is a function which is then increasing or decreasing the cutting line in comparison to what we just identified here. This has an effect. We will see this in the LMD system later on. But first, let me just export. And I also give it a name. And save. With this, XML file was created, which can be opened in the LMD afterwards. I just told you that I also did so because you cannot only identify these dark blue spots, what I did before. In another pixel classifier run, I identified these dark violet spots. So if you want to identify different things, of course, this is possible. From here, let's go back to the LMD. Now we are back at the LMD software. What we have to do now is importing the XML file we just created with the Aivia. For this, I go to Import Shapes, and I have to choose the XML file I just created. I open it. I didn't store reference points, so I have to press No. I want to show you how you define them. So you can now focus the reference points, and you have also to bring the cross directly into the middle of the T in this case, so which is quite fine at the moment. So I say OK. This is the second one. I focus again a little bit. Rotation is quite fine. Say OK. Same procedure for the third one, and I press maybe a little bit to the left. And I say OK. I want to save them now. Sample is inserted, and I want to use the current magnification for the import. This will take some seconds to minutes, I would say, according to the number of areas. So in this case, we roughly have 7,000 areas, so this will take a while. So now import is ready, as you can see. And if I just run a little bit around here, you can see that there's also different colors. Why is this? So you can tell the system which region should be collected in which collection well. So this tool is called the Edit Collector Assignment. And I now assigned just from 1 to 2000 to collection well 1, from 2 to 4000, and so on in collection well B, C, and D. You could also do this by area, so the large ones in one collection well, the tinier ones in another collection well, just as an example. You could also tell the system, please put one of these regions of interest into one well of a 96 well plate, so to separate everything. Everything is possible here. Now, with it, so you did your import, so you now could cut, or you now can cut your dissectates or your regions of interest, and then afterwards do your downstream analysis. And from here, you are done.